Choose one.
Okay, going ahead and jumping back into it. We are going to be working with APIs, functions, dplyr in the next couple videos, and we're going to spend a lot of time in extraction mode because bringing in this data is going to be a little bit nuanced and a little bit intricate. So let's take our time in doing this. So what we're going to do is open up our directory, our main directory, go to R, go to ETV cycles, go to 4, and then just go ahead and move this in here. Boop. And then what I'm going to do is I'm going to open up Positron. Okay, Positron. Boop. Open that. We're almost good to go. Let's go to the desktop. There we are. All right. So we're going to close this because that's what we worked on the other day. And go to ETV cycle 4. And here we go. For a little bit, I'm going to work out of the viewer mode, and then I'll go into the actual source mode. So in this situation, the API is what we're going to be using to be able to interact with the server. Okay, so an API stands for Application Programming Interface, and we're going to go to this weather website and extract data to be able to answer these questions. So what do daily high and low temperatures trends look like across several California cities? San Luis Obispo, San Diego, and I think Los Angeles. We'll see. How does the relationship between daily temperature range and precipitation differ across those same cities? And then are the days with large temperature ranges also days with more or less precipitation? So we'll answer those 3 questions with this data. So I'm going to kind of mention what each of these libraries that we want to bring in. The very first 2, I'm going to even show you. I actually moved my console to the right. I can move it back below. Didn't know I can do that, right? So we need to install 2 packages. Okay, at least you need to install 2 packages. In those 2 packages, you see how to use the vector C. Those 2 packages are HTTR2. Okay, that allows you to make different requests to a server. Okay, in terms of the website. And then for us to be able to work with the data a little bit differently once it comes into R, it's called a package called JSON Lite. JSON Lite. Okay, so those are the 2 packages that we're going to need you to install. Okay, so the very first, once you install those packages, the very first package that you're going to load is HTTR2. Okay, not 3, but 2. And that's for data extraction. Data extraction, building and sending HTTP requests, building and sending HTTP requests, JSON Lite. JSON Lite. That's again for data extraction. And that's going to be in terms of parsing our JSON responses. If you're not familiar with JSON, you will after these series of videos. Responses. Then we're going to utilize this per package. So per should have definitely been installed when you installed the tidyverse. And that's going to allow us to iterate through multiple cities. Okay, so we should be a little bit familiar with iteration in terms of the LFM videos. Repeating request. Dplyr, okay, for data transformations. Dplyr. I'm just going to hold off on writing those things in. We're going to use that to, again, data transformations. Lubridate, we want to be working with some dates. Lubridate. We're going to be transforming data into a longer format. So we're going to use tidyr. And last but not least, we're going to make some visualizations with ggplot. Okay, so ggplot2 is what we need to install. ggplot2. So there we go. So I'm just not really an answer to this, but like this extraction is going to be a little challenging in that it requires a number of steps. And I don't want to just throw the function at you that we're going to build. I want us to build this learning, at least this function, but learning each and every step and what it's exactly doing. So it's imperative that we take our time through this and, I guess ask questions by way of email and things of that regard. All right. So with that being said, let's go ahead and jump right into it. So learning moment one, what's an API? An API allows us to make requests to a server. On the back end of the server, ideally it's a database that we can actually get that data from. Instead of using a CSV or Excel sheet or even an HTML page that we did last cycle, is that those mechanisms don't change often. Ideally the county every single year is going to change for, so forth. But when it comes to a server or a database, more specifically, it's going to be updated like continuously every 5 minutes, for example, in terms of temperature. So working with that kind of data is huge, right? You can expect yourself seeing something like that in the future. Okay. So the website is this. I actually never been to this website, but actually locally on my machine. But the thing is with this database, which is really nice, is that we don't necessarily need any security authentication that is typically used with other databases. We could go through this, documentation, but that's neither here nor there. I'm gonna do most of the heavy lifting in terms of, the syntax, in terms of the information that we want. But if you ever want more information, here's the website. But again, going back to the authentication, we don't have to go through that process, and we're lucky with that. So in terms of answering this question here, I'm going to go to source because that's what I like. In terms of answering this question here, why might an API be better than manually downloading the file, is that an API can be better when data changes often. Okay, when we want to automate repeated pulls or request, or when we need to request only a specific slice of data. And that's actually huge. That's going to come up in video, I think 2 or 3, where it's like you're going to get inundated with so much information, but it's nice that we have this functionality to select some of it, not all of it, to then create a data frame from. So that is, one of the biggest benefits of actually utilizing APIs rather than just having a set HTML file and just scraping it, or having a CSV file that has a whole bunch of data that may not necessarily be used in your analysis. So that's that. I know I'm just going to go back and forth. Sorry about that. So going back to source mode, visual mode. I'm going to pause this. Okay, so right now I actually had to move a file name of the image, and I'll put that in the directory so you can have it as well, at least on Canvas you can have this as well. So whenever you see it's called API JSON workflow, make sure you have that as well. So what this workflow allows us to do is say that, okay, we're making a request. We're going to make a request, right? We're going to format it so that's going to be a GET request, right? We're going to contact the API, open Medio, and then we're going to get a response, then finally clean it and turn it into a data frame. So that's learn by doing thought process, request. Make sure it's in the right kind of query to open Medio, and then process our response and then turn it into a data frame. So when it comes to APIs, as you can see through this image, you're going to make a request, you're going to get a response, it's going to be in JSON body. Boom. That's it, right? But the request needs to be in a certain format. The response is going to be in a certain format. We need to turn that response into a data frame. Ideally, it works. Okay. Ideally, we get, we make the right kind of request. So here, we're going to make the request. Okay. Boom. And I did not want to, I made it, everyone to type this. I didn't mean to do that. So it's going to be a request, and then the HTTP. Okay, the URL that we're going to use, you know what, I'm going to type URL here. So URL is going to be, I'm going to type this 1 second. I didn't waste time. I don't want to waste time. I was going to make a mistake, but here, I'll still type because it's important to note this. So it's going to be api.open-mateo.com / and then I'm going to add a couple more things. V1, okay. And then we're going to do forecast. And then that is the URL in and of itself. So instead of using quotations here, I'm going to copy this and then just put URL. So that's the base. We can even call it base URL. Okay, the base URL. And we're going to use this base URL throughout the videos. But I just need you all to see that once I set this base URL, I can actually get a preliminary setup of what the get is going to look like. So if I just run this, okay, that should make sense because I didn't run the sales before. Okay, boom. Now that I run this, okay, so let's remove this and talk about some things. So here it's telling me, okay, so here it's telling me that I'm doing an it's coming from HTTR2 request. It is a get. There's different types of requests that you can make. There's get, there's post, there's pull, there's I think update. One of the put or delete, the CRUD mechanisms if you're a CS person. And so what we're doing here is just a get because we are just getting information. Okay, and currently the body is empty. We're not necessarily specifying anything in the body as of yet. Okay, so we're setting up the preliminary information for us to make our first request. And I'm intentionally doing this so that we don't necessarily get overwhelmed. So this is just the beginning elements of our requests from the weather website. Okay, so let's answer some of these questions because they're important. So so when it comes to what does request do at this step? What request does, it creates an HTTR to request object pointed at the base URL, okay. And the reason why we want to do this is so that we're able to then add to this request separately from the actual base. Okay, so it's imperative that we at times still separate our logic so that we're not overwhelmed. Okay. The next question says, why is the default HTTP method get here? Get is the HTTP method used to retrieve data. Since we're not necessarily modifying the database, we're not adding to the database, we're not deleting it or updating it or creating new things. The get is automatically the default. So get, I should capitalize it because it's actually low-key important. Get is the HTTP method used to retrieve data without changing anything on the server. Okay, so since we're asking for weather data, not submitting, modifying, get is the correct and default choice. Okay, there's other methods, but we're not going to be working with those. Okay. And then lastly, in terms of the questions here, what is a JSON? The actual formal definition is that JSON is a JavaScript object notation. And I'm pretty sure it has spaces in it, but you know, my typing is interesting. JavaScript object notation. Okay. It's a lightweight. It is a lightweight mechanism of transforming or storing, let's do that, storing data that is in key value pair. And so in the back of your mind, like, what is key value pair? You probably, maybe you've seen this, but like, say for example, I can put the key would be name, for example. Okay, and let's say location or latitude is another key. Lat, because I'm not gonna embarrass myself, and then latitude, longitude, longitude. Okay, will be another one. Okay, so object. Okay, JavaScript object notation is a lightweight mechanism to store data in key value pairs. So what that looks like is, in terms of a JavaScript notation, for those that are unfamiliar, a key could be, let's say, name, and then the value would be slow. Another key could be lat, then another value would be, I don't know, 39. And then same thing in terms of longitude. Launch can be another key, and then the actual value would be, let me say, 45. Okay, that's the logic of a JSON, right? It's a lightweight of actually storing data. Okay, it could be nested. We're gonna see nested in a little bit, but don't fret. So with that, what I mean by nested is like another. This could be a key, right? And then this could be another key with a bunch of different values, or a bunch of other keys and other values. So don't worry, we'll see in a little bit. All right, so with that being said, we are almost done with this video. Let's just go through, well, not necessarily done, but this is an important part. Learning moment 2, planning our first query. Okay, so technically speaking, we're going to look up San Luis Obispo. So let's do that. Type San Luis Obispo. And that's fine, but truth being told, what we really need to give, or make, in terms of making our request, we need to give the API the longitudinal latitude of our location. Okay, not necessarily the city name. Okay, so it doesn't currently work by just city name, or it could, but this working API does not use purely the city name. Video 3, you'll see why I'm including the city name. Or maybe it's kind of obvious that we kind of just still need to know what we're labeling. This is 35.2828, and then the longitude, is negative 120.6596. Okay, so this is the information that we're going to use in our request. Okay, this is the information that we're going to use in our request. However, the information that we want from the server is the following variables: temperature. We're gonna put this in quotes. Temperature. I gotta spell this correctly, okay? Because in terms of interacting with the database, it needs to be correct. It needs to be accurate. At this current moment, I'll be honest, 2M, I don't know about. I know max is the maximum temperature. Okay, so then we need the max. Okay, then we need the min. And then we need precipitation. Precipitation underscore sum. Okay. And so the reason why we're separating it out in this kind of format, just so that we can make our modifications, if we need them to be more easier for us to do in the future. Okay, so that's why I'm separating out my daily variables, the variables that I want from each day, and the actual city that I'm considering. Okay, so that's that. So I'm going to run this, and then stored. That's fine. That's neither here nor temperature. That's neither here nor there. Some small questions. This is just making sure that we're on the same page. What does the city name longitudinal latitude and longitude group define? They define the target location, the human readable city name. I'm going to say here name for labeling. Okay, because we need to make sure that we know what the data represents. Okay, what cities they're referring to. What does the daily variables define, and why is it stored separately? It defines which weather metrics we want the API I'll change that. API to return. Okay, so that, say for example, I want, I guess Gust. I can then, add that to the actual vector. Okay. And then why is it helpful? Why is it helpful to storing it as a separate object keeps the request code cleaner and makes it easier to add and remove variables. And I kind of said that. All right. So why is it helpful to save the query input to as objects before building the request? So you can see we haven't made the request yet. We're going to do that in the next video. But the reason why it's nice to do this is because we're able to make the code easier to read and easier to change. Okay. So that is it for this video. We're going to then now formalize the request in the next video and actually check if we got some good results in this next line. Thank you. And then we can specify, okay, San Luis Obispo slow. That's embarrassing because I'm not moving in my office.